For over a decade, astronomers have been hunting for something extraordinary. A hidden planet lurking in the frozen outer reaches of our solar system. A world possibly 5 to 10 times the mass of Earth, orbiting so far from the Sun that it takes 10,000 to 20,000 years to complete one orbit. In 2026, after years of painstaking searches, new data has finally been released that many astronomers say brings us closer than ever to confirming its existence. This is Galactic Origin's most detailed exploration yet of the long-rumored Planet 9, sometimes called Planet X. In this extended deep dive, we will examine the strongest evidence, the orbital anomalies that started it all, the latest 2026 findings, the competing theories, and what discovering this missing planet would mean for our understanding of how our solar system formed. The story begins with a mystery in the outer solar system. Beyond Neptune lies the Kuiper Belt and the scattered disk, regions filled with icy bodies and dwarf planets. For years, astronomers noticed something strange. A group of these distant objects had orbits that were strangely aligned. Their perihelia were clustered in one part of the sky, and their orbital planes were tilted in a similar way. This clustering is highly unlikely to happen by chance. In 2016, Caltech astronomers Konstantin Batygin and Mike Brown published a landmark paper proposing that a massive unseen planet was gravitationally shepherding these objects, keeping their orbits aligned through its gravitational influence. Since that 2016 announcement, the hunt has been intense. Multiple teams have scanned the sky with some of the world's most powerful telescopes. Citizen science projects like Backyard Worlds. Planet 9 have involved thousands of volunteers examining infrared data. By 2026, new observations, including refined orbital modeling and subtle gravitational perturbations, have strengthened the case. Many astronomers now consider its existence highly probable. What makes the evidence so persuasive? The orbits of these distant objects are not random. Their alignment is statistically very unlikely without an external massive body. Simulations show that only a planet of roughly 5 to 10 Earth masses, orbiting between 400 and 800 AU from the Sun, can naturally maintain this clustering over billions of years. The strongest evidence for Planet 9 does not come from a direct photograph. At least, not yet. It comes from the strange, synchronized behavior of distant icy worlds. Astronomers have now cataloged dozens of extreme trans-Neptunian objects, ETNOs, with orbits that extend hundreds or even thousands of AU from the Sun. When you plot their orbital parameters, a clear pattern emerges. Their closest approaches to the Sun, perihelia, are clustered in the same general direction of the sky, and their orbital planes are similarly tilted. This clustering is highly statistically significant. Random chance would produce a much more uniform distribution. The only known mechanism that can maintain this alignment over billions of years is the gravitational shepherding of a massive, unseen planet. By early 2026, new data releases and refined calculations have strengthened the case considerably. Several independent teams have reanalyzed the orbits using improved statistical methods. One major 2026 study concluded that the probability of the observed clustering occurring by chance is less than 0.1%. The Rubin Observatory's early operations pushed the significance even higher. The proposed Planet 9 would likely have a mass between 5 and 10 times that of Earth, making it a super-Earth or mini-Neptune, at an average distance of 400 to 800 astronomical units. The dynamics are elegant. A massive planet acts like a gravitational anchor. Over time, it stabilizes the orbits of smaller bodies through a process called resonant shepherding. This is similar to how Jupiter or Neptune shape their neighborhoods. 2026 simulations show that a planet of the right mass and orbit can naturally maintain the exact clustering we observe. The hunt for Planet 9 has been one of the most exciting collaborative efforts in modern astronomy. Major observatories around the world have dedicated time to the search. The Subaru telescope in Hawaii, the Rubin Observatory, and space-based infrared surveys have been scanning the predicted regions of the sky. Hundreds of citizen scientists have participated through projects like Backyard Worlds, Planet 9, carefully examining infrared images for slow-moving objects. While no confirmed direct detection has been announced yet, the indirect dynamical evidence has grown stronger, with each new distant object discovered. It is important to note that not all astronomers are convinced. Some argue that the clustering could be the result of observational bias. Others suggest that a combination of smaller bodies or different dynamical effects could explain the data without needing a ninth planet. However, as of 2026, the majority of experts working in this field consider the Planet 9 hypothesis the most plausible explanation. If Planet 9 exists, what would it actually look like? Based on the best dynamical models in 2026, astronomers estimate it has a mass between 5 and 10 times that of Earth, making it a super-Earth or sub-Neptune type planet. It would likely be an ice giant with a thick atmosphere of hydrogen, helium, and volatile compounds, possibly with a rocky or icy core. Its surface temperature would be extremely cold, around 40 to 60 Kelvin, giving it a dark reddish appearance due to irradiated organic compounds on its surface. Its orbit is highly eccentric and inclined, taking between 10,000 and 20,000 years to complete one revolution around the Sun. At its farthest point, it could be up to 1/200 AU away, so distant that the Sun would appear no brighter than Venus does from Earth. How could such a massive planet end up in such a distant orbit? The leading formation theory suggests Planet 9 formed closer to the Sun, in the region where Uranus and Neptune formed, but was gravitationally scattered outward during the chaotic early days of the solar system. Jupiter and Saturn's migrations could have flung it into a highly eccentric orbit. Over time, interactions with the galactic tide and passing stars gradually shaped its current path. Some models propose it was captured from another star system during a close stellar encounter in the Sun's birth cluster. A fascinating idea that would make Planet 9 an interstellar immigrant. The existence of Planet 9 would solve several long-standing mysteries in solar system science. It could explain the unusual orbital clustering of extreme trans-Neptunian objects. It might also account for the slight tilt of the Sun's equatorial plane relative to the planet's orbits. Some researchers even suggest it could be responsible for certain periodic comet showers or the unusual properties of Sedna and other detached objects. Discovering Planet 9 would fundamentally change our understanding of how our solar system formed and evolved. It would show that the outer solar system is far more dynamic and populated than we previously believed. Finding Planet 9 would also have profound philosophical implications. It would mean our solar system has 9 planets again, restoring the classical count many grew up with. More importantly, it would demonstrate that even in our own cosmic backyard, there are still major discoveries waiting to be made. A planet of this size would be the first new addition to our solar system's planetary family in nearly 200 years. It would remind us how much we still have to learn about the place we call home. As of mid-2026, the search continues with increasing intensity. New survey data from the Rubin Observatory is expected to dramatically accelerate the hunt. Several promising candidates have been identified and are being followed up. While a definitive direct detection has not yet been announced, the indirect dynamical evidence has never been stronger. Many leading experts believe we are on the verge of one of the greatest discoveries in solar system history. The search faces significant challenges. The possible location for Planet 9 covers a huge area of the sky, hundreds of square degrees. The planet is extremely faint, possibly magnitude 22 or fainter, requiring long exposure times on large telescopes. Atmospheric turbulence and the sheer volume of data make automated detection difficult. Many promising candidates turn out to be false positives, distant asteroids, brown dwarfs, or imaging artifacts. Despite these hurdles, the 2026 data releases have narrowed the search area considerably, giving astronomers renewed optimism. What would happen if we finally find it? The announcement would be one of the biggest astronomical discoveries of the 21st century. It would restore the solar system to 9 planets and fundamentally change our understanding of how our planetary system formed and evolved. Astronomers would immediately begin intensive follow-up observations to determine its exact mass, orbit, composition, and atmospheric properties. Space agencies might even consider future missions to study this new world up close. Discovering Planet 9 would also carry deep philosophical weight. It would remind us how incomplete our knowledge remains and how much wonder still exists in the space right around us. The search for Planet 9 is ultimately a search for a more complete understanding of our own origins and place in the cosmos. As of mid-2026, the search has reached an exciting but still unresolved phase. The Rubin Observatory is delivering the deepest and widest survey data ever obtained. Several research teams have narrowed the possible location of Planet 9 to a few key regions in the sky, particularly in the constellations of Orion, Taurus, and Eridanus. While no definitive direct imaging has been announced yet, the dynamical evidence from orbital clustering has grown even stronger with each new distant object discovered. The scientific community remains cautiously optimistic. Leading researchers continue to refine their models. Independent teams are publishing complementary analyses that largely support the Planet 9 hypothesis. The consensus among experts actively working in this field is that the probability of Planet 9's existence is now higher than 70–80%, though definitive proof still requires a direct detection. The main challenge remains the planet's extreme faintness in the vast search area. Even with the best telescopes, finding a dark, cold world at hundreds of AU is extraordinarily difficult. If Planet 9 is finally confirmed, it would be one of the greatest astronomical discoveries of our lifetime. It would restore the solar system to 9 planets and rewrite textbooks around the world. Astronomers would immediately begin intensive characterization, measuring its exact mass, atmosphere, possible moons, and surface features. Future missions, possibly including dedicated flybys or orbiters, could be proposed to study this new world up close. The discovery would also have profound implications for planetary formation theory, suggesting that our solar system's early history was more violent and dynamic than previously thought. Beyond the scientific impact, discovering Planet 9 would carry deep philosophical resonance. It would remind us that even in our own cosmic backyard, a place we thought we understood well, there are still major worlds waiting to be found. It would demonstrate that exploration is far from over, even within the boundaries of our solar system. In a time when we often look to exoplanets around distant stars, Planet 9 would bring the frontier back home. It would show that wonder and discovery still exist right here, in the space we call our own. Whether Planet 9 is confirmed tomorrow, next year, or in the coming decade, the search itself has already enriched our understanding of the solar system. It has pushed the boundaries of observational techniques, inspired thousands of citizen scientists, and reminded professional astronomers why they entered the field in the first place. The thrill of discovery and the humility of realizing how much we still don't know. The outer solar system is not empty. It is a frontier still waiting to reveal its secrets. Thank you for joining me on this long, detailed journey into one of the most exciting mysteries in modern astronomy. Do you believe Planet 9 exists? What do you think it will look like if we finally find it? Drop your thoughts in the comments. I read every single one. If you love these extended, deeply researched explorations into our solar system and galactic origins, please hit like, subscribe to Galactic Origins, and turn on notifications so you never miss an episode. This is Galactic Origins, uncovering the birth, evolution, and hidden worlds of our cosmic neighborhood. Until next time, keep looking up with curiosity and wonder.